Hi, hello my dear students. To continuing my lecture on kinematics, the subtopic motion in one dimension or motion in straight line chapter. So today I would like to discuss types of velocity. Types of velocity. Types of velocity. Already I discussed types of speed in previous lecture. So in this lecture I discuss types of velocity. If you know the types of speed, what are the types of speed, just you go through the previous lecture. If you know the previous lecture, so definitely it is easy to learn this types of speed also. So please go through previous lecture. So now types of velocity. First one is uniform velocity. Uniform velocity. If your body moves with constant velocity throughout motion, so if your body moves with constant velocity, this is very important mark. Constant velocity throughout its motion, then the body is said to be in a uniform speed. The body is said to be moves with a uniform speed. So uniform speed, here the main thing is velocity is constant. So velocity is constant means what is constant here? Magnitude is constant. Magnitude of velocity is constant because velocity is a vector quantity. If velocity is a vector quantity, it has both magnitude and direction. Magnitude of velocity is constant and direction of velocity is also constant. Magnitude of velocity is constant and direction of velocity is also constant for the uniform velocity. For the uniform velocity, magnitude of velocity is constant and direction of velocity is also constant. Next, non-uniform velocity. So if your body has constant magnitude but a different direction, varies direction. For example, let us consider one car. The car is traveling on the road. It is moves with a velocity 50 kilometers per hour. First 1 hour it moves 50 kilometers per hour north direction. Next 1 hour it is moves with the same 50 kilometers per hour only, but it moves south direction. Next 1 hour it will move 50 kilometers per hour magnitude speed only, but it moves east direction. What we observe from this? From this we observe the speed of magnitude. Magnitude is constant. Velocity magnitude is constant here, but direction is changes here. That means the non-uniform velocity means if magnitude is constant, direction is varies, or direction is constant, magnitude is varies, or both magnitude and direction varies. So varies throughout path, then the body is said to be in a non-uniform velocity. I hope you all are understood this one. If a magnitude is velocity, magnitude is constant, direction is varies. Otherwise, direction is constant, magnitude is varies. Sometimes both magnitude and direction is varies. This is called non-uniform velocity. Whenever body has magnitude is constant, direction is varies. Direction is constant, magnitude is varies. Both direction and magnitude will be varies. Then the body is said to be moves in a non-uniform velocity. Next, third type. So next, I would like to discuss third type. Uniform velocity, non-uniform velocity. Next, instantaneous velocity. Instantaneous velocity. So before going to discuss instantaneous velocity, I explain one example. If direction is varies, magnitude is constant. For example for direction of velocity is varies. Direction of velocity is varies, but magnitude is constant. Magnitude is constant. What is the example for this one? So velocity, direction is varies. Direction varies. Magnitude constant. So what is the best example? Uniform circular motion. Uniform circular motion. So for circular motion you should consider. Circular motion. Observe carefully circular motion. For this circular motion, so these are the velocity vectors. This is the velocity vector. So how to find direction of velocity? Whenever we draw the tangent to the circle, tangent means touching line. Whenever we draw the touching line to the circle, that is called tangent. The tangent is indicates direction of velocity. Tangent is indicates here direction of velocity. Here these are the directions of velocity. So observe carefully. While body is make a circular motion, it is moves in a circular motion. It will moves in a circular motion. Definitely it will changes direction continuously. For example, first direction is like this, another one direction is like this, another one direction is like this, now direction is like this. That means for made a circular motion, definitely direction of velocity is changes continuously, but magnitude of velocity is constant. This is the best example. Body moves in a circular motion, velocity vector, direction of velocity is changes continuously, but magnitude is constant. This is the best example for the non-uniform velocity. Now it is non-uniform velocity. Bodies moves in non-uniform velocity because direction of velocity is changes. Direction of velocity changes continuously, but magnitude of velocity is constant here. Next, third type. Next third type, I would like to discuss third type, instantaneous velocity. Instantaneous velocity. Third one, instantaneous velocity. Instantaneous velocity. Now, what is meant by instantaneous velocity? If a body has velocity at a particular time or instant, body has velocity at a particular instant, is called instantaneous velocity. So if any body has certain velocity at a particular instant means the time here. At a particular time, if a body has a certain velocity, that is called instantaneous velocity. So here instantaneous velocity is equal to instantaneous velocity is equal to limit delta t extends to 0, dx bar by dt. Observe carefully. Instantaneous speed also we indicate same like this, but bar vector is not here. Vector s bar we are taking here. There that in case of instantaneous speed we are taking here just dx. Dx, that means here delta x we are taking delta x bar by delta t. We got here dx bar by dt because velocity is a vector. In case of uniform speed, instantaneous speed, just I indicated dx by dt because it is a scalar quantity. If it is a vector, then definitely it indicates bar on head. So because velocity is a vector quantity, that's why I indicate here bar on head. In case of instantaneous speed, just I indicate ds by dt. This is a difference between instantaneous speed and instantaneous velocity. Velocity is a vector quantity, that's why I mentioned bar here. Speed is a scalar quantity, that's why it doesn't mention any bar on that head. That is important thing. So instantaneous velocity formula, this is dx bar by dt. Next, the most important type, average velocity. Average velocity. This is very important. Average velocity. Average velocity. So average velocity is defined as the ratio between total displacement traveled by a body to the total time taken. So ratio between total displacement traveled by a body to the total time taken. Total displacement traveled by a body to the total time taken is called average velocity. So this is most important formula. So we use this formula in case of solving problems. Average velocity is equal to total displacement by total time taken. So this is a formula for this average velocity.